Hello, let's have a look at virtual memory in this video, which is a topic which students often think they understand, but they have a couple of misconceptions about it or are just not precise enough in how they write about it in exams. So let's try and go through this and cover all the things you need to know about. We're going to start by not even talking about it. We're going to start by talking about RAM. So RAM is our key component relating to virtual memory. What RAM does, as a recap, is hold all open programs and files. RAM looks like this. We have anything open on my computer will be copied into RAM so that the CPU is able to execute it. Something like PowerPoint is a program. Something like this file here is a file. Both are held in RAM. Now, let's say this is reaching maximum capacity. I've got maybe 8 gigabytes in RAM, and these things here collectively take up just about 8 gigabytes. If I wanted to open another program, I double click Word to try and open it. We have an issue because I've reached maximum capacity. Potentially, the computer won't let me open more programs. I might get an error message, it might not let me open Microsoft Word. Equally, it might cause something to crash. So it might cause one of these other programs to crash. It might try and open Word, but Word crashes. It's not a good situation to be in when you get near to this maximum capacity. So virtual memory was invented to try and give you a better option when we reach or near maximum capacity of RAM. Without it, these two options in red would occur. Now, virtual memory, hence the name virtual, isn't actually a real memory device. It's not like RAM and ROM or a CD or a hard drive, which actually physically exist. Virtual memory is managed by software, specifically the operating system. It's not the CPU doing this, it's not an actual component you would find in your computer, it's a software solution to this problem. So how does virtual memory work? Well, when RAM is reaching maximum capacity and we try and open a new program or file, we haven't got space for it currently. So what the operating system will do is, first of all, take a program or file which hasn't been used recently and move it from RAM to secondary storage. And that summarizes what virtual memory does. We are using secondary storage as an overflow space for programs and files. So this will free up a space in RAM for the new program or file to be copied from secondary storage into RAM. So this can be hard to follow. So let's try and look at an example of this. Right now, I've got RAM being full. It's full of programs and files. Now, all of these would actually be on secondary storage anyway. It would just be a copy of these in RAM, but that complicates things a little bit. So let's imagine I want to open Microsoft Word. Okay, Microsoft Word would be sat on secondary storage anyway, but I need to be able to move a copy of this into RAM so that it can be executed. The issue here is, of course, I've reached maximum capacity, so let me try and use virtual memory. Well, let's say PowerPoint was the program I haven't used most recently. Maybe I've got Chrome open, I'm watching YouTube on it, but PowerPoint is sat in the background. Let's try and copy this into secondary storage. Now, PowerPoint being secondary storage means I can't actually use it right now, but I can put it there temporarily, which frees up space for me to load Microsoft Word into memory. So now Microsoft Word can be opened, can be used because I've now got space for it. Now, really importantly, programs and files in secondary storage cannot be accessed by the CPU. To be accessed, it has to be in RAM. So let's say I want to start working on my PowerPoint again. Well, if I want to use PowerPoint, I can't just access it in secondary storage. I need to move this PowerPoint program back into RAM. So at this point, we repeat the process. So maybe Chrome is the next oldest program in RAM. We instead are going to move Chrome into secondary storage, into this virtual memory. We then can move PowerPoint back into RAM so that I'm able to use it. And then if I wanted to use Chrome, we would do the same process. We would swap one of these back and move Chrome back into RAM. So that last point about moving things back into RAM is often forgotten about or misunderstood. We cannot access stuff in secondary storage. It's only via RAM. So we have to constantly swap things in and out in order to allow there to be space in RAM. The key benefit of doing all this work is we're able to effectively extend the capacity of our RAM by using secondary storage as a pretend bit of RAM. The key downside is it is slower to access programs and files in virtual memory because we have to do the swapping process going backwards and forwards between RAM and secondary storage. And also, generally speaking, secondary storage is a lot slower than RAM to read and write. And a final point is, for all of this to work, there must be enough capacity free in secondary storage to allow this to happen. If you're at maximum capacity in secondary storage, well, you're in trouble. We can't use virtual memory because there isn't enough space to do so.